This is the Python project showcase for Team 1 of Section 5 of the Engineering 133 class. Our team members include Sajan Seberg, Lexi Loyat, Andrew Mamedov, and Jack Christensen. Image processing can solve many engineering problems that require quantifying by observation. Computers can create more precise calculations than the observations of the human eye, so image processing can be more efficient at quantifying by observation than humans. Using computer software for image analysis is particularly useful for observing large quantities or observing visual inputs over long durations of time. One unique problem that image processing can solve is measuring crop growth to improve growth efficiency for hydroponic systems and smart farms. Measuring the plant growth efficiency of hydroponic systems is very important to the industry when contrasting crop yields with traditional farming methods. Measuring crop yield outside of harvest has proven to be challenging for hydroponic systems, so introducing imaging technology allows for crop yield measurement in much greater capacities and with significantly less labor than before. It can also detect problems with the plant, such as disease and abnormal growths. Take a look at the sample images here on the right. The top is an image taken digitally with a camera, and the bottom is the returned image that has gone through image processing to filter out inputs other than the actual leaf area, leaving the user with a result of just the leaf area. Next, we'll take a look at a demonstration of how our code works and the inputs that it allows.
Our error check is a simple if-else statement. The program looks for a .png in a variable user underscore image, and this is where the user inputs an image file. If the image file has a .png, it gives an output of you input the right file, and if the file is anything other than a .png, it outputs a not a PNG file. Try again with a PNG file, because the PNG file is the only thing that will work with our code. So I have saved pictures of me and my aunt, same picture, as a PNG and a JPEG to show that it works. So I input the .png file, it says you input the right file, and then it turned the picture into grayscale. But if I run it again and put the same picture as a JPEG file, it will tell you that it's not a PNG file, and that I need to try again with the PNG file. And the code won't work. It'll output a blank screen.
Okay, so this is our Python project. I'm going to give you a brief rundown of our code. I will show you how the program works, and then I will also give you an example of an error or not saving the file. So first, we have our kind of section where we import all of our libraries. Basically, anywhere out in the functions, if we call to something in a library, this is where it comes from. And then we have our user input. Basically, we ask the user for an image file, and we make sure it's in PNG format. If it's not in PNG, we will tell them to try again, but use a PNG file. So basically, they need to type .png, and then it'll end the code. Then we have a grayscale function. Turns the image gray, kind of in the name. Same thing as this next one. So this is edge blurring and noise smoothing. We have 4 functions that are involved with this one. Basically goes through, smooths any edges, and then blurs it as well. And then we have edge enhancement, which basically takes gradient and finds theta, and it's used in edge detect, which basically goes through and also looks at pixel by pixel, detects any edges, turns those white. If it's not an edge, it will turn it black. That's kind of what this section is for. Then it shows the image to the user in this black and white format, as you can see in the plot section, and then it'll prompt the user to either save it, and if they say yes, it'll ask them what they want to name the image, and if and then it saves it from there. If they don't, then it ends the program. So from our directory, we have the Python project, we have the Purdue Arch, and we have new coins.png, sorry. So we're gonna do coins first. Coins.p. Actually, we'll try coins. So what this shows is, since we didn't type PNG, it's thinking that it's not a PNG file. And so what we're going to do is we're going to try again. Basically, we're going to do coins.png, hit enter, and as you can see, the code is actually running this time. Basically, that check just makes sure that whatever image we're getting as an input from the user is a PNG file. And so as you can see, here's the image that's outputted. It is the edge detected image. So our original image was just of some handful of coins, and now it has gone through and given us the edges in white. As you can see, they kind of went a little bit into the center of those coins. And so it asks us if we want to save the image. So we're going to actually say no for this one and show you how to do it later. But basically, to say no, just type N, and it will basically end the code from there. So let's try Purdue Arch. Purdue underscore Arch dot PNG. Let me try that one more time. Purdue underscore Arch dot PNG. Sorry, yeah, I messed up there. So basically, this is going to run the exact same program as last time. Oh, I must have included a space at the end on this one, which is why I didn't register it. So be sure when you're doing these to make sure it's just the file name and you hit enter. And so there we go. This is our image. We're going to say yes, we're going to save the image. What do we want to save the name as? We're going to call it new Purdue underscore Arch. And then hit enter, and it saves the image. So if we check our directory, we have new Purdue underscore Arch. That's exactly what we wanted. So this has been a run through of our code. Thank you very much.